Hello, good morning. Last time we have done a little bit of discussion on the firewall, the placement of the firewall in a small data center, and F5 load balancers servers, right? So, why do we need a DMZ zone, internal zone, two types of firewalls, perimeter firewall, internal firewall, right? In this session, we will just focus on the little more focus on the load balancer. We will try to have some bits and bytes from the load balancing, right? We will try to connect the dots. We will try to connect the technology, different technology with this one. So first of all, we have a server. This is a web server, server 1, server 2, server 3. Okay, we have a load balancer over here. This is another VLAN 30. This is a one network, 192.168.1.0/24. This is complete one network. It's hosted on the L2 network, right? So you can see this is, and the VLAN 30 for this is acting as an L3 for this one. It's acting as an L3, and this VLAN 30 is over here is defined on this one. Okay, this is connected to a router via L2 switch, and this internet gateway is on the connected via internet. So I have a client sitting over here, somewhere over here. This is a public IP address 203.0.113.45. Right, I have some client sitting on the internet external world. He want to access one of the services over here, which has an HTTPS. Okay, and the services are built on any one of these three server. So how things work? So the laptop goes to the make a request. It will go to the internet gateway router. So first thing first, this is a public IP address. Internet will perform the NAT over here, right? And this will do NAT 192.168.1.100. And you can see this 192.60.190 sorry 192.168.1.100 is a VIP, virtual IP of all these IP of these all these three server. So it is mapped, whether it's a statically you could do it, right? This will then go to the forward to the firewall. You can make a policy on the firewall to allow this traffic towards the this zone. Okay, once it is passed through the policy of the firewall, then it will go to the load balancer, and load balancer will do some kind of use some kind of a load balancing technique, whether it's a round robin or weighted round robin or least connection, whatever is configured, or first come first serve, and it will go to the server, right? Server will respond back via load balancer, then it will go to the firewall, and then firewall will forward to the router, and it will go outside the wall. So this is how the hide hide line of how the communication would be done. Okay, so a lot of the things over here in the firewall, you can see I want this firewall to act as an SSL offloading. Okay, so what is an SSL offloading? SSL offloading, last time we had done a discussion. Whenever there is a external client sitting and he want to make a connection, he want to make a communication to any of the service and application, he could not go via open internet, right? He would like for some secure connection, because internet is not secure, and it's so we need some kind of a security. So SSL tunnel or TLS tunnel, whatever the tunnel we call it, right? So that is why we are using HTTPS to have this web application. So what the load balancer will do? Load balancer will do the SSL offloading. So instead of all the stress on the server, we are uh, leveraging load balancer and not having so much of an stress on the fire servers, right? So they will do the SSL offloading. So we will have a tunnel from here to the client, but this is a unencrypted. That would be encrypted, and this is a decrypted session from the server to the firewall, right? For the SSL offloading, what do you need? You need a public and a private key. Private key should be with the load balancer itself. You need a public key, and you will send this to the global root CA, right, to issue a digital certificate. And this has to be signed by the list of the trusted CA, anyone like a Intrust, DGCert, right? So these some of the, we have a 9 or 10 trusted CAs, which is listed on a list. So that has to be issued by one of the trust trusted CA. Okay, then this load balancer should have the certificate. We can we use the self signed root CA? You can use the self signed root CA, but that, because you are not communicating only with the inside, right? If it's self signed root CA is good when you're communicating with the inside of the server. You're communicating with the outside of the server also, outside in the internet also. If you don't have a proper certificate, the things will not work on this laptop, right? It will give a certificate error. You always see when you do this, there will be always a certificate error, and they will ask whether you want to proceed with that site or not. So it could be a issue. So if you are a good if you're a renewed organization, if you're in the production, you need a global certificate, and a private key should be over there, right? So you need a certificate over here. So we already talk about the SSL offloading. Certificate comes in the picture, SSL tunnel comes in the picture, public and private key comes in the picture. So there is an SSL offloading, right? There's one more thing called the SSL bridging. And what is an SSL bridging? We will just give a definition. So instead of terminating the over here, the we will do this up to here. The So some of the clients will ask that, no, my server, I need a end-to-end communication to be a secure tunnel, right? I don't want to terminate this SSL or SSL offloading on the F5 load balancer. I want the communication has to be done from the server, from client to server, right? So in that case, you will terminate. So you will use the another kind of an offloading. It will SSL, right? So that's a SSL the SSL bridging. The concept is called the SSL bridging, right? So you have a load balancer terminate on this SSL TLS connection, okay, and so one is SSL offloading. SSL offloading, that load balancer will do this decrypted, right? It will have a one job, decrypted, and from here to here it's on the HTTP, and you don't need any kind of a certificates or a profiles over on this one. For SSL bridging, it's a end to end. It's from server to client. Then load balancer will do a SSL termination. It will decrypt, then it will encrypt and make one more tunnel over this one. So this is called SSL bridging, right? There's one more thing called the SSL pass through. You can just have a look on this, in which case we will use an SSL pass through. But mostly in the production, you have an SSL. You will heard about the SSL offloading and SSL bridging, right? Bridging, you will have a complete over here, but in the middle of this firewall, it will do the job. It will decrypt the SSL tunnel, it will terminate the SSL tunnel, and then it will encrypt the SSL tunnel with this servers. So from here to here, it also, the path is also secure. In SSL offloading, the path is secure up to the F5 load balancer, okay. So there will be no extra stress over here, and there's no extra work needs to be done from the uh, administrator on these servers regarding to the certificates and profiles, correct. Server load balancer will do two type of NAT, DNAT and SNAT. So the DNAT, they will do for the incoming traffic, Okay, so they will the traffic 192.168.1.100 will will be on the F5 load balancer. F5 load balancer, suppose it has choose the server to 1.11, right? So what it will do, it will change the destination of the source from 1.100 to 1.11, that is known as an DNAT, while the return traffic is going through the load balancer only. You can see the default gateway is configured as a 1.100, right, as a VIP, right? Or you can we can also have one interface configured like 1.101, something like this, right? Or 1.99 over here, not on the VIP but 1.99 for this interface, right? You can configure it. Then in that case, it will return traffic will also go to the load balancer. Then the load balancer will do the SNAT. It will change the source with the 1.11 to 1.100, and it will forward the traffic to the parameter firewall. And then from parameter firewall, it will go to the this one, the NAT router. The NAT, we will change the source also on the NAT router also, because it will the traffic seems to be 1.100, but it should be a 2030.113.45, because the client would not understand the private IP address, right? So we will do a NAT over here, we will do a NAT over here. There is a DNAT, we will do the DNAT, we will do the SNAT. And when we do both the natting over here, this is called the full proxy. When we have the both of this, there is a called the full proxy. One more thing on this F5 load balancer, that this is a one arm deployment. So there are two kind of a deployment, majorly broadly one arm and two arm deployment, right? We will discuss in the next video what is a two arm deployment with a different example, but this is a one arm deployment we have, because we are just using a one arm, and we are using for this internal network. And this is an LTM, local traffic manager. It's not a global traffic manager, it's an LTM F5 load balancer we are using, which could use with the different license for the SSL offloading and all those stuff, right? But this is for the local. This traffic is distributed on the local servers or the local line. So this is a one arm. It has only a one arm connected to the switch, and this is with the same interfaces, right? There's no external or internal. This belongs to only one of the network, that is 192.168.1.0. Okay, thank you.